Dear student, due to coronavirus, school started online classes for your study. So you can subscribe Golden Flower Palia YouTube channel, like and press the bell icon.
Hello students, in this video lecture we are going to discuss today electric potential due to electric dipole on broadside on position. Okay, so now there it is a point in question which is lying on the right bisector of the dipole. We have to draw a line which is perpendicularly pass from the center of dipole, and this point is now lying at the that right bisector. Okay, so what will be the electric potential due to the dipole at this point? Okay, so today's lecture it is based on potential at right bisector of the dipole. So now there it is the second case, broad side on position. Okay, so we are going to calculate electric potential at broad side on position of electric dipole, and for this we need to draw a dipole and figure related to that. Okay, so now this is a dipole. We have minus q charge, it is lying on the left hand side, and plus q charge, it is lying on the right hand side. Okay, so this is the center of the dipole. Let's consider it is A and it is B and it is O, and distance from O to A it is small l, and from O to B that is small l, because the charges are kept at 2l distance apart from each other on a dipole. So as I told you that this point is lying on the right bisector, so I have drawn this right bisector, not very good straight, but we can take the work from that one. So this is the right bisector, and this point is lying on the right bisector of the dipole, and here we have to complete this figure, meet point A and point B with point P. Okay, let this point is lying at r distance apart from point O. Okay, what is the value of BP? Okay, what is the value of BP? It is L, it is R. Using the Pythagoras theorem, the hypotenuse it is equal to under root R square plus L square. Okay, the same will be here also. A and P at a distance of under root R square plus L square using Pythagoras theorem. Okay, and as I told you in the last lecture that due to the positive charge electric potential is positive, and due to the negative charge electric potential is negative. And one more thing you have to keep remember, that potential is a scalar quantity, not a vector quantity. Okay, so when we calculated individually due to positive charge, due to negative charge, the electric potential at any point, then to find out the total potential, we need to add them together algebraically. Okay, so algebraically we will add them together. First we will find out the electric potential due to positive charge and due to negative charge individually at point P. So what is the electric potential at point P due to positive charge plus Q charge? So electric potential at plus Q charge, sorry, at P due to plus Q charge. Okay, so due to positive charge Q, what will be the electric potential at point P? That will be equal to V1 1 upon 4 pi epsilon naught, that is Q by, and the distance of point B, that is positive charge from point P, that is under root R square plus L square. So we will keep it as it is, under root R square plus L square. Okay, once again I am recalling your memory that V is equal to 1 upon 4 pi epsilon naught Q by R. There it is no square on distance. Okay, so we have to keep the thing, this R square and L square under root as same. Okay, due to minus q charge. Okay, due to minus q charge, what will be the electric potential at point P? V2 is equal to, because it is a negative charge, so electric potential at point P due to minus q, that will be negative. So minus 1 upon 4 pi epsilon naught, that is q by under root r square plus l square. So now we have two values of electric potential, 1 upon 4 pi epsilon naught q by under root r square plus l square, and the same thing it is in negative sign, okay, due to minus q charge. So what will be the net potential at point P? So net potential at point P will be equal to V1 plus V2. Okay, so just keep the value 1 upon 4 pi epsilon naught q by r square plus l square square root minus 1 upon 4 pi epsilon naught q by under root r square plus l square. So now we have the two equal values, but one is in positive sign, another is negative sign. So two quantities are difference, we are subtracting from each other. Equal quantities we are subtracting from each other. So net potential due to the dipole at the right bisector, at any point on the right bisector, that will be equal to 0. It's a very important result because numerical can be asked on this property of the dipole. Okay. So here we will discuss one of the numerical from this property especially. Students, you can see on your screen there is a question. The two charges minus q and plus q are located at points A. The coordinates are given 0, 0, minus A, and B, that is 0, 0, plus A respectively. How much work is done in moving a test charge from point P, that is having the coordinates 7, 0, 0, and to Q, that is having the coordinates minus 3, 0, 0. Okay, so there it is, two charges which is equal and opposite and kept at point minus A and plus A, that is on Z axis, and we need to calculate work done to move a test charge from point P to Q, which is lying on the x axis, because the coordinates are given 7 and minus 3, that is on x axis. Okay, write this question in your copy. Okay, copy this question and then we are going to solve it. So here we have A is equal to 0, 0, minus A, and the minus q charge is kept at point A, and B, it is 0, 0, plus A, the coordinates of B, that is on the charge it is kept plus q. And the point P and Q having the coordinates 7, 0, 0 and minus 3, 0, 0, which is lying on the x-axis. So here we need to draw first the figure of this question, and then afterward we are going to use the property of the dipole at perpendicular axis, which is passing from the center of the dipole. Okay, so we have one figure, that is, this is suppose it is the z-axis and it is the x-axis. Okay, just for the reference we have taken this, and now there it is point minus A and plus A. This is minus A, this is minus A, and this is plus A, and at the plus A there it is charge plus Q is kept. Okay, it is similar to the dipole. This arrangement is similar to the dipole. The total distance between minus q and plus q, it is 2a. Okay, so this arrangement is quite similar to the dipole. So minus q is, it is kept on minus a, and plus q it is kept on plus a, and on the z axis. Okay, so on the x axis there are 2 points, that is p and q. So P is lying here at the 7, the distance of 7, that is P, and the distance of 3, there it is Q minus 3. Okay? So downside. So this axis is passing from the center of this arrangement of minus q and plus q, that we can consider as a dipole. So at the point P, what will be the potential? There it is. And at the point Q, what will be the potential? There it is. So this is the axis which is passing from the center of dipole, and here we can see that at point P, just now we have calculated at the center of dipole, if any axis is going to be passed from the right bisector, if there it is any point on the dipole, there the potential will be equal to 0. So what will be the potential at P? Vp is equal to 0. And what will be the potential at Q? That is Vq is equal to 0. Because at the right bisector of the dipole, the potential is 0 at every point. Whatever the point, wherever it is lying on this right bisector, whether it is on line 7, whether it is lying at 5, whether it is lying at 1. So if the point is lying on this right bisector, the potential is going to be 0. So at point P, the potential is 0. At point Q, there it is, potential is 0. And now we are shifting a charge Q naught from point P to point Q. Okay. So potential difference between P and Q, it is equal to 0. So what is the definition of potential? Potential's definition, VPQ is equal to WPQ upon charge. Okay, this was the definition. The definition of potential difference is work done to shift a charge from one point to another point in an electric field. Okay, so when we are shifting any charge from one point to another point, whatever the work is we are doing against the electric field, that work done, it is called potential difference between that two points. So potential difference between that two points, suppose we are doing the work done VPQ, and the charge that we are shifting, that must be a positive unit positive charge, but here we have taken Q naught, so we have to divide this equation by Q naught. So Q naught charge we are shifting from point P to Q, so total potential difference is equal to WPQ upon Q naught. Okay, so what is the potential difference between P and Q? That is 0 minus 0, it is equal to 0. So WPQ upon Q naught. Okay. Okay. So WPQ is equal to Q naught into 0. So WPQ is equal to 0. That's a very simple question. Okay, using the property of electric dipole when the point is lying on the right bisector of the dipole. Okay, and the broadside on position. So this was the broadside on position, and on the broadside of position of electric dipole there is a potential 0. So when we are shifting any charge from 0 potential to 0 potential, we have not to do any work. Okay, so the work done to shift the charge will be equal to 0. Okay, so thank you very much for this video now today. And in the next lecture, we are going to discuss the electric potential at any point of the dipole.
Do self study at home and stay home, save lives. Thank you very much.